Okay, so we will start today's lecture now. In the last class, we studied about the concept of work done by a force, the concept of negative work, and that emerges when the force and the displacement are opposite to each other. And I had told you not to judge the negativity or positivity of a work by the direction of individual forces and displacements, but rather by simply checking whether the force and displacement are mutually opposite to each other or in the same direction. If the force and direction are both negative, still the work will be positive because both of them are in the same direction. And now we will start solving some numerical problems related with virtual work. And we will learn how to solve for unknown quantities in a given system by using the concept of virtual work. And let me just remind you what was the concept of virtual work. The concept of virtual work simply says that if there are n number of forces acting on a system, and in this case, let me draw a system as a box, and there are, let us say, n number of forces acting on it in any direction, F1, F2, and all. And if the body is in equilibrium, so in order to use the concept of virtual work, the first word that you have to look for in any question is equilibrium. So until and unless the system is in equilibrium, you cannot use the concept of virtual work. So let us say that this system under the action of some n number of forces F1, F2, F3, F4, Fn is in equilibrium. And if it is in equilibrium and we give it a virtual displacement in any direction of our choice. Now, the concept of virtual displacement was also explained to you in the previous class. It is a very, very small displacement, imaginary displacement given to the body in order to create a sort of thing what we call as virtual work. See, work is force into displacement. If the displacement is virtual, then the work will also be virtual, and hence the name virtual work. So we have given a small displacement, let us say delta R to the body. Now, the virtual work done by individual forces will be F1 into delta R, F2 into delta R, because the whole body has moved by delta R. So this will be the dot product of all individual forces with the displacement F3 into delta R. This will be the virtual work, and let me use the notation of small u to represent work. So this will be delta U1, the work done by F1. This will be delta U2, work done by the second one, and delta U3, work done by the third one. So if I simply go on adding the virtual works done by individual forces and I add up all the work done, these are all virtual works, okay, done by the forces. And since there were n number of forces, I am adding up all the virtual works. And the principle of virtual work says that since the body was in equilibrium, the sum of all the virtual works will come out to be zero, no matter how you take it. So this is the concept of virtual work, and we are going to use it. Now we will go to a numerical problem. Look at this problem. See, I have drawn out a roadmap for you to remember the steps of solving any problem using virtual work. So if you practice the concept of virtual work using these steps, you will find that any problem would be easily solved by you. So we will be practicing by taking these steps individually on one or two problems. Now look at this problem. Determine the force Q required to maintain the equilibrium of the linkage shown in figure 7. Neglect the effect of friction. Now this is the linkage. Look at the linkage and let us understand the mechanism of the linkage first. See, let me take a pen here. Okay. This is an empty slot, and this link can move up and down inside the slot. Okay. This is a hinge provided at point A so that this link can easily rotate in both directions about point A. This is also a pin link. This is also a pin link. This is also a pin link. Okay. And now look at this mechanism. If I move this point by applying a force in the forward direction, then the linkage will extend like this. This is the frame of the link. This link will actually rotate and become more flatter like this. This link will come down and you will get an image like this. If I move this point backwards, then I will get something like this. So this acts like a scissor. जैसे अपनी कैंची होती है ना, वैसे कैंची जैसा एक मैकेनिज्म है. It can be extended in the forward and backward direction like this. So if you extend it in the backward direction, these linkages will come closer to each other because these are all hinged links. These are all hinged links, and rotation is allowed about each of these links. And when you bring it closer to the frame, this point will climb up. And when you take it away from the frame, this point will climb down. Similarly, when this point is taken away, you can see that this point itself will move in the direction of the applied force P, and this can be moved backwards also. So did you understand the linkage? ये जो मैकेनिज्म इस प्रॉब्लम में दिया हुआ है, क्या ये आपको मैकेनिज्म समझ में आया क्या? कोई एक जना मेरे को माइक ऑन करके बोले, प्लीज कंफर्म.
Yes, sir.
Now let us see what the question is. Now the question says, find force Q. You have to find the amount of Q required to maintain the equilibrium of linkage. So what is the question here? P force is already applied, and the question does not say how much is P. P कितना न्यूटन है ये नहीं दे रखा. It is not given. It is simply said in the problem that if some force P is applied at this point, then obviously if you do not apply a force Q in the upward direction, this link is going to move downwards. Why? Because this whole mechanism will get extended like this. This whole mechanism will get extended like this, and this point will climb downwards to this point. Now the question setter is asking you, how much should be the force applied at this location in the upward direction so that Even though the P is trying to pull this link in the forward direction, this force Q will not allow the linkage to move. So this Q is supposed to be known. So the problem is simply that कितना Q लगा के रखूं मैं इस जगह पे जिससे कि यहाँ पे P लगाने के बावजूद ये लिंक चल ना पाए. In other words, the linkage or the mechanism becomes or comes into equilibrium. So what should be the value of Q in terms of P? Okay, this is the question. Now we have to use the concept of virtual work. Now let us take the steps of virtual work one by one so that we understand how to solve every problem using the same steps. The step initially that has to be taken, or the first step always, is to draw the active force diagram. Active forces के बारे में पिछले क्लास में बताया था. Active forces are those forces which are capable of producing virtual work. So let us see. How many forces can you see in this linkage? There are a lot of forces, and mainly if I ignore the forces in the rods, because in the rods the forces will be mainly cancelling out each other. So if I look at the external forces only, force P is already applied. Force Q has to be applied by U to stop the motion of the linkage because of P. At A, there will be reactions. So if this linkage is in tension, then the reaction at A will be like this. And instead of taking the reaction at A like this, you could also do one thing. You could easily take the components of reaction and say that, okay, the direction of force on A is in this direction. So therefore, there could be two components of the reaction at A, and that could be reaction A vertical and reaction A horizontal. We don't know the directions, or I would rather like to keep it as a mystery right now, because eventually if we use a proper technique, the directions of reactions and all unknown forces can be corrected, auto corrected in time. But anyway, for now I am saying that there will be two reaction components. So in my problem I actually have 1, 2, 3, 4 forces that are supposed to be drawn. So 4 external forces are definitely there in the problem. But an active force diagram will not necessarily involve all the forces drawn in the figure. The active force diagram will ask you, out of these 4 forces, 1, 2, 3 and 4, how many forces can produce work? Now let us look at this thing. इनमें से कौन कौन वर्क प्रोड्यूस कर सकता है. See, if I apply a force here, forget about all the other forces, then this point is capable of moving. This is free. So if motion of this point is allowed, that means P can produce work. So this is an active force. If I apply a force in the upward or downward direction and I forget about all the other forces, then obviously I can say that the point D is free to move up or down in this slot. So if motion of point D is possible, which is also the point of application of force Q, so I can easily say that Q is also an active force. Now look at the forces RAH and RAV. Are they capable of producing motion? No. Because this is a pin joint, this joint cannot move either in the forward upward direction or forward horizontal direction. It cannot move. So since the motion of point A itself is restricted, and although there are forces acting at point A and deprived of motion, these forces will never be able to produce work because this is hinged and fixed at A. So rotation is allowed, but motion is not allowed. So RAH and RAV will not be able to produce any work. So if I am asked that this is your question, this is the linkage, and you draw the active force diagram, not the FBD. active force diagram, then I will say that the image itself is the active force diagram. Now look at the image given by the problem setter himself. प्रॉब्लम सेटर ने इसमें ऑलरेडी दो फोर्सेस लगा करके दिए, पी तो हमने लगा रखी है पहले से ही, और आपसे पूछा जा रहा है कि क्यू कितनी लगाए, how much q has to be applied so that despite the application of p here, the whole linkage comes in equilibrium and there is no motion. So this is the active force diagram. So I hope that the concept of active force diagram that I explained to you in the previous class and the active force diagram that is drawn here or presented before you is clear now. So active forces only are included in active force diagram. Reaction forces can be taken in an active force diagram, which we will see later. In some cases, only when the point at which the reaction is being developed is free to move. But in this case, this point is fixed to the ground. It is not able to move. Therefore, the reactions being developed here will not form active forces. So anyway, there are only two active forces. So our step number 1 has been accomplished, which says draw the active force diagram. So this is done. Now let us move on to the next step. Select a stationary point like top, bottom or corner of some fixed wall in the diagram as origin. अब आपको आपका जो डायग्राम है उसमें एक ऐसा पॉइंट चूज करना है जो कहीं चलता नहीं हो, और उस पॉइंट के रेस्पेक्ट में आपको बाकी डिस्टेंसेस लेंगे. सो एन ओरिजिन हैज टू बी सेट एंड प्रेफरेबली ये मैंने आपको एग्जांपल्स दे रखे हैं कि किस पॉइंट्स को आप ओरिजिन सेलेक्ट कर सकते हो. So origin has to be selected a point which has no scope of motion in the given figure. And if we go back to our figure, this point A becomes the perfect candidate for origin. So I will say that A is my origin. So I have set the origin also. So now all the distances that I will be measuring in my problem will be with respect to this origin. Okay. So let us go back to the steps. This step is also completed. I have selected the origin as a fixed point. Now coming to step 3, it says mark the distances x1, x2, x3, etc. from the origin to all those points which carry horizontal forces in the diagram. तो ये क्या कह रहा है कि आप अपने फिगर में आपने एक्टिव फोर्स डायग्राम तो बना ही रखा है. एक्टिव फोर्स डायग्राम इज ऑलरेडी डन. नाउ गो बैक एंड चेक आउट ऑफ ऑल द एक्टिव फोर्सेस हाउ मेनी फोर्सेस आर हॉरिजॉन्टल. तो मेरे पास दो ही एक्टिव फोर्स है. वन एक्टिव फोर्स इज Q and another active force is P. And now I have to check out of all the active forces. In this case, there are only two. How many horizontal forces are there? There is only one horizontal force. So this step says from the origin, mark the distance of each horizontal force with x1, x2, x3. So since there is only one horizontal force, so I have simply marked it as x. See. And from where have I measured it? See, this is being measured from point A, which is your origin. So I measured the instantaneous position of point F, which is the application of the horizontal force. मैं इधर से इधर तक की distance क्यों measure कर रहा हूँ? क्योंकि मेरी horizontal force यहाँ बैठी है. This is the location or the seat of my horizontal force. So I marked it as X. And I did not use x1 and x2. Why? Because since there is only one horizontal force, I don't need to use x1, x2. अगर मेरे पास और भी horizontal forces होती तो मैं x1, x2 use कर लेता. But in this there is only one, so I use x. And similarly, this step says mark distances y1, y2, y3 from the origin to all those points showing vertical forces. अब आप अपने फिगर में जाकर के उन फोर्सेस को आइडेंटिफाई करो जो कि वर्टिकल है. So I go here, I see that there is only one force left and this is vertical. So from the origin, this point, I mark the instantaneous position as y. And again, as you can see, I am not using y1, y2, etc. Why? Because there is only one force. If there were multiple vertical forces, then I would have used y1, y2. So this step is also complete, that you selected an origin, and from the origin you marked the distances as variables, x, y variables of all the horizontal forces are marked as x, and all the vertical forces distances are marked as y. So this step is also complete because I have marked x and I have marked y. Now let us go back and see what is the next step. Establish relations, usually geometric relations, between all x and y variables in terms of some common variable, for example, theta. Now, in this next step, if I read out this statement, you are simply going to get confused. So let me just display here how to do what this step is telling you. See, if this distance is x and this distance is y, then you can clearly see from the image that x and y are both being controlled by another common variable theta. Can you see here? So if I increase theta, increasing theta means taking this point backwards. So you have to put in a little bit of imagination here. If I draw this point inwards, then this link is going to climb upwards like this by rotating in this direction. And that is how theta increases from its present value. So if I forcibly try to change theta and increase, you can see that the variable x will decrease and the variable y will increase. Got it? With the increase of theta, x will decrease and y will increase. So what I am going to do is I have to establish a relationship between x and y using this common variable theta. Now how can I do that? This can be easily obtained with the help of a geometric relationship. If I draw an imaginary perpendicular line here, see, this angle is theta. What is this total length? See, all the lengths are given as L, L. All the individual lengths are of length L. Okay. So this complete length is 2L. So what will be the length of this one? This horizontal line. Can anybody tell me this distance? I'm asking about this distance. This is theta. This is 2L. What will be this horizontal distance? Anybody?
Under root 4L square minus y square.
No, give me in terms of L and theta.
12 cos theta.
12 cos theta.
Yes, this question mark is 2L cos theta. What is this remaining distance? This distance. Can anybody tell me? See, again.
X minus 12 cos theta.
No, I again want it in terms of L and theta. If this is theta, look at the linkages. This will also be theta.
L cos theta, sir.
So yes, you are correct. This distance will be L cos theta. So now tell me, what is the value of x in terms of L and theta?
3L cos
X is equal to
3L cos theta.
3L cos theta. This is the actual meaning of this step. To establish x and y in terms of theta. Now use this same geometric reasoning. I will give you a hint here. I'm going to give you a hint and you have to come up with the same relationship or similar relationship for y now. I can draw a horizontal construction line here. See, this is again L, this is again L, this is theta. So tell me, what will be the value of y in terms of L and theta? Anybody, please make a calculation on your own and tell me. It's simple geometry.
12 sin theta.
Yes, very good. See, if you look at this construction, if you use a little bit of logic, this is theta, this is L, right? So if this line is L cos theta, then obviously this vertical line must be L sin theta. And similarly for this one also. These are same links. See, this is L, this is L. So if this is L sin theta, this must also be L sin theta. And twice of L sin theta will be equal to your y. So eventually your relationship becomes y is equal to twice of L sin theta. So this is what this step is actually asking you to do. So up till now, you have done establish relations between all x and y variables in terms of some common variable, which will generally be theta. You will find that most of the problems will involve a theta angle, and you can find a relationship between theta and x. Why are we doing this exercise? Because we want to eliminate two variables and bring only one variable in the equation. That is the purpose, to simplify our problem. Now let me just take it to the worksheet here. So we have established y as 2L sine theta and x as 3L cos theta. This relationship has been understood and taken down by us. Now, additionally, what it is saying, remember to correct the sign of the relation. Increase or decrease with respect to theta, with respect to the common variable. तो अब हमको ये यहां पर अपना काम खत्म नहीं हुआ. अब अपन को ये चेक करना है कि आपने x और y का थीटा के टर्म्स में जो रिलेशनशिप बना लिया है, क्या वो पॉजिटिव रिलेशनशिप है कि नेगेटिव रिलेशनशिप है. नाउ लेट अस सी व्हाट इज द मीनिंग ऑफ दिस. Once again, look at the mechanism here and tell me by using your imagination and logic that if I increase theta, the magnitude of theta is increased, will the value of x decrease or increase? Tell me.
So decrease.
It
Increase.
will decrease
Decrease.
because this point will have to move backwards, and if this point moves backwards, the value of x will become shorter. X distance will become shorter, but at the same time this point is going to climb upwards. So that means if I increase theta, the
One will
value of y will increase. So this is the relationship between theta and x and y. If theta increases, x decreases. If theta increases, y decreases. Sorry, y
Sir,
increases.
y increases.
Now, this represents a negative relationship and this represents a positive relationship. So what I have to do is, although I have established the relations mathematically for x and y with respect to the common variable theta, now I have to put a proper sign depending on whether with respect to theta the main variable is increasing or decreasing. So now look at this relationship. This says that between theta and x there is a negative relationship, and between theta and y there is a positive relationship. Positive relationship means if theta decreases, y also decreases. If theta increases, y also increases. So if y is following the same trend as theta, then that relationship is called as a positive relationship. On the other hand, X is following a reverse relationship with theta. If theta increases, X decreases. If theta decreases, X increases. So X is always trying to follow the reverse step of whatever theta is doing. And this is called as a negative relationship. So now what I will do is, I will correct these two equations by putting the proper sign also. So what I will do, I see that X and theta have a reverse relationship. So I will correct this equation by putting a negative sign here, minus 3L cos theta. What about this one? Do I have to change this equation or should I let it remain the same? Y and theta. Should I put a minus sign or let it be positive only?
So let it be positive.
Let it be positive
Positive.
only, because y and theta have a positive relationship. So it will be plus only. So I have corrected the sense of x and theta and y and theta. And with this, I have completed this step. So step number 4 is also complete. We are actually doing this step for the first time. So maybe you will get a feeling that this is a little bit complicated. But once we move on from one problem to another, and similarly, if we keep on solving 2 or 3 problems, then you will see that this becomes a habit. And this is not going to take not more than 5 minutes for any problem for you. So this is the first time. So be patient. I will repeat these steps again and again so that you become well versed with the process of doing this. And I have delineated these steps specially for you, because if you go and refer to multiple books and try to understand the concept of solving problems using virtual work, you are definitely going to get confused. And let me tell you, these steps that I have given you, you will not find in any single textbook. You will not find it anywhere. This I have developed especially for you because I myself got confused when I looked at the textbooks. And many textbooks don't even give any reason for why work was taken as negative, why work was taken as positive. You will see that despite the force and displacement being in the same direction, in some textbooks the work done is taken as negative, and you will not get any idea why that is taken, and you will get confused कि सर ने तो हमें बताया था कि भाई ये पॉजिटिव होता है और इसमें किताब में नेगेटिव ले रखा है. So that is a different approach, and many books follow multiple approaches. So in order for you to avoid all sorts of confusions, what you need to do is stick to the plan given here. You will never get your answer wrong if you stick to the exact plan given by this 6 steps here. So that is what we are doing. We have established 4 steps here. And now let us go to the 5th step. Take the derivative of all relations to get relations for all del x and del y. Now this step is pretty much easier. And if you already know the concept of differentiation, then it must not be difficult for you. So what I want you to do is find the derivative of the first expression. And since this is the first time, let me do it for you. If I take the derivative of all variables on both sides of the equation, I should be writing it as dy is equal to, since small l is a constant value, so there will be no differentiation for it. So 2l will be taken as it is. Okay, let me take it here. Dy is equal to 2l cos theta d theta. Is this correct or wrong? Please somebody tell me. Who is confident in differentiation, please tell me if this differentiation is correct.
Correct.
This is correct. Instead, in many textbooks, instead of taking the traditional dy and d theta, they simply use del y equal to 2l cos theta del theta. So this, if you see something like this, you should not be unfazed. And since most of the textbooks are following the notation of del instead of d, I will also be using del y, del theta, del x instead of dy d theta. But all you have to remember is the process is exactly the same and there is no difference whatsoever in what differentiation means here. Okay, so I will avoid using the dy d theta notation and I will go with del y and del theta. Now I want somebody who is confident to perform the differentiation of x and theta with this equation. Perform differentiation of this equation and give me the correct expression.
3L sin
Del
theta
x is
d theta.
Del x is equal to 3L sin theta del theta.
Very good. This is the correct expression. Why? Because the derivative of cos theta is minus sin theta. And that minus and this minus will get cancelled out. And eventually what you will get is del x is equal to 3L sin theta del theta and del y equal to 2L cos theta del theta. So this has also been established. And with this, you finish this step also. Take the derivative of all relations and get del x and del y. But still it is not clear why we wanted the value of del x and del y. See, this is the preparation for creating your virtual work. If you remember the concept of virtual work, any force has to be multiplied with a small imaginary displacement. Do you remember that? So if a small imaginary displacement is required to create the virtual work, which we will call as del u, we need a small del x. And that is why this differentiation step comes in. This is why you have to do it. You simply cannot take and say कि भाई किसी लिंक को 1 मीटर मूव कर दो और वो वर्चुअल डिस्प्लेसमेंट है. No, the virtual displacement has to be so small that it is barely visible with your naked eyes, and that is why you have to take derivative, and these displacements are virtual now, or infinitesimally small, or we are very very near to imaginary displacements. This is the concept and logic behind taking the derivative. तो ये मेरे ख्याल से समझ में आ गया कि भाई ये डेरिवेटिव वगैरह क्यों ले रहे हो. सिर्फ रटना नहीं है अपने को, अपन को समझना भी है कि एक एक चीज अपन क्यों कर रहे हैं, अपन ने ये काम क्यों किया. Why did you replace all x and y in terms of theta? So that in your equations the number of variables to be solved becomes lesser. आपको दो वेरिएबल सॉल्व करने की बजाय अब सिर्फ एक थीटा से डील करना है, and then eventually you take the derivatives. And now let us come to the last step. आपके del x del y प्रिपेयर हो गए, small virtual displacements are ready, and now give the system a small virtual displacement, example del theta. Now please remember that your del x is in terms of del theta, your del y is also in terms of del theta. So if you give a small virtual displacement to your body in terms of theta, then automatically delta x and delta y will get created. देखो, if I give a small increment to theta here, मैं इस लिंक को थोड़ा सा ऊपर ले गया, कितना del theta से ऊपर ले गया, ये एंगल कितना है, this is del theta. So if I slightly change the location of the link at this location, then the complete mechanism will change and this point will move backwards by del x, and this point will move slightly upwards by del y. Do you understand the concept here? चूंकि x और y ऑटोमेटिकली थीटा से रिलेटेड हैं, तो थीटा में अगर छोटा सा डेल थीटा का वर्चुअल डिस्प्लेसमेंट दोगे तो डेल्टा x और डेल्टा y अपने आप क्रिएट हो जाएंगे जिस डायरेक्शन में क्रिएट होने थे उनको. दिस इज द कॉन्सेप्ट. ओके, नाउ वी गो बैक, and now what you have to do is come to this linkage and tell me what is the virtual work done by the force q here. q से कितना virtual work create हुआ ये बता दो मेरे को कोई भी. By creating a small virtual displacement delta theta here, delta y was created in the direction of q. So what is the virtual work of q? Anybody? Q into delta y. That's it. भाई वर्चुअल वर्क क्या है? वर्क तो फोर्स इंटू डिस्प्लेसमेंट है ना, तो वर्चुअल वर्क क्या है? फोर्स इंटू वर्चुअल डिस्प्लेसमेंट। थीटा को यहां पर आपने थोड़ा सा बढ़ाया तो डेल्टा वाई ऊपर को चलेगा, डेल्टा एक्स पीछे को चलेगा। So Q into delta Y is the work done by force Q. Now please somebody tell me what is the work done by force P? The virtual
P
work
into
done by force P.
P into delta X.
It is P
Sir,
into
P delta X.
it is simply P into delta X. That's all. Now you have to tell me again by applying your logic. Out of these two virtual works, this is the first virtual work by the first force, that is Q. This is the second virtual work done by the second force, which is P. Now tell me, out of these two works, which one is positive and which one is negative?
Sir, Q delta Y positive होगा.
This is positive. Why? Why is it positive?
सर वो डेल्टा Y पॉजिटिव होगा इसलिए.
No, wrong reasoning. डेल्टा वाई पॉजिटिव होने से नहीं ये वर्क पॉजिटिव हुआ, ये डेल्टा वाई और क्यू एक डायरेक्शन में है इसीलिए ये पॉजिटिव हुआ. प्लीज रिवाइज योर कॉन्सेप्ट अगेन. आई हैव टोल्ड यू कि वर्क को पॉजिटिव किस तरीके से लेना है. डेल्टा वाई पॉजिटिव है इसीलिए नहीं लेना. डेल्टा वाई और क्यू एक ही दिशा में है इसीलिए पॉजिटिव है. एंड this virtual work is negative. Why is it negative? Not because delta x is in the reverse direction, but because P and delta x are opposite to each other and therefore work done will be negative. Please always remember it like that only. So now, what does the principle of virtual work say? Principle of virtual work says that in my problem, there were two forces, P and Q. These were the two active forces. Okay. P produces a virtual work delta U1. So this is delta U1. Q produces a virtual work of delta U2. So this is delta U2. You take the proper sign. This is positive. This is negative. And the virtual work principle or the principle of virtual work says that the summation of all virtual works of a system which is in equilibrium must be equal to 0. So this is what you have to apply here. So all you have to do is simply say that first virtual work Q into del Y, second virtual work, add it with the first one. The second virtual work is minus P into del X because P and del X are opposite to each other. The sum of these two must be equal to 0. Now this equation will automatically give you the value of the unknown force Q that had to be applied at D so that it keeps the system in equilibrium when P force is already pulling at point F. P फोर्स जो है वो F को ऑलरेडी पुल कर रही थी. आपसे ये पूछा गया था कि कितना फोर्स Q लगाएं यहां पर D पे जिससे कि ये पॉइंट आगे चल ना पाए. ठीक है, ये क्वेश्चन पूछा गया था. एंड वी अप्लाइड दिस होल नंबर ऑफ स्टेप्स हियर एंड इवेंचुअली वी केम अप विद दिस इक्वेशन. एंड नाउ लेट अस प्लेस दिस इक्वेशन. नाउ लेट अस ट्रीट इट मैथमेटिकली. ओके, this is our delta x, this is our delta y. So what I will say is P into delta x was negative, so I will say minus 3L sine theta del theta into P. What is this? This is P into del x, and I have put the negative sign also. I have put the negative sign also. Plus Q into delta y. So delta y is this. So I will use 2L cos theta del theta into Q. This whole thing comes out to be equal to 0. Now I will quickly try to simplify the equation. L can be taken common from both sides, both the terms. So L and L will go and merge with 0 and become 0. Del theta and del theta are again common quantities in both the terms. So I will combine them, bundle up and divide by 0. It also goes away. So my equation simplifies to minus 3 sine theta into P plus 2 cos theta into Q. Now my objective is to find Q. This is equal to 0. This is the equation. So I can take this negative quantity to the right hand side. 2 cos theta into Q is equal to 3 sine theta into P. So what is Q? 3 by 2 tan theta times P. This is your answer. Did you understand what we did here? This is your answer. 3 by 2 P tan theta. Now this took a lot of time. We almost have exhausted our allotted time for the lecture here. It's almost 10:50. But it took a lot of time because I was explaining the concept and the fine features of the steps that you have to take in very, very minute detail. But if still there is somebody who has not understood any single aspect of what I told here, please put on your mic and please tell me that कि सर ये हमें समझ में नहीं आया. We will take one more day for virtual work. In the next class, we will take up a little bit of more complicated problem, and then we will take problems related with beams, जिसमें कि आपकी moments का work भी आएगा. So we will take up more complicated problems, but you will see that if you follow these steps, you will never falter and you will never fall into trouble. आज जो मैंने आपको समझाया, ये कितने लोगों को समझ में नहीं आया, ये मेरे को एक बार आप माइक्रोफोन ऑन करके बता दो. And you have understood it perfectly what we have done here. Please tell me that also.
सर एक डाउट है लेकिन
पूछिए.
सर वो जैसे थीटा कब इंक्रीज करना है कब डिक्रीज करना है किससे पता चलेगा?
आप हमेशा इंक्रीज कीजिए थीटा को, और डिक्रीज करोगे चाहे इंक्रीज करोगे उससे कोई फर्क नहीं पड़ेगा. लेट मी एक्सप्लेन इट हाउ. ठीक है, मैं इसको जरा समझा देता हूं. आई वॉन्ट ऑल ऑफ यू टू आस्क क्वेश्चंस लाइक दिस. जैसे आपने अभी पूछा है, आपका नाम क्या है बेटे जिन्होंने पूछा है? व्हाट इज योर नेम? अजय. अजय इट्स वेरी गुड दैट यू आर आस्किंग क्वेश्चंस. और मैं जानता हूं कि कई सारे लड़के जो हैं मन में डाउट्स लेके बैठ जाते हैं, पूछते ही नहीं है. बट यू हैव टू आस्क, क्योंकि जब तक आप पूछोगे नहीं मुझे नहीं समझ में आएगा कि आपको क्या प्रॉब्लम है. ओके, लेट मी एक्सप्लेन दिस. ठीक है, योर लिंक वाज लाइक दिस. This is your place where you applied the force P, and this is the place where you applied the force Q, and this is your origin, and your theta is here. आपने क्वेश्चन ये पूछा कि हमें ये कैसे पता लगेगा कि थीटा को इंक्रीज करके देखें या डिक्रीज करके देखें. मैंने अपने प्रॉब्लम में थीटा को इंक्रीज करके देखा था, कोई दिक्कत नहीं है. अब अपन उल्टा करते हैं, थीटा को डिक्रीज करते हैं. अब अजय आप ये इस फिगर में देख करके बताओ. यू नो दैट दीज आर ऑल लिंक्स. ठीक है, ये सब लिंक्स हैं और कैंची की तरह काम करते हैं. अगर मैं थीटा को नीचे की तरफ टिल्ट करके डिक्रीज करूं तो आपका एक्स जो है वो बढ़ रहा है कि कम हो रहा है? आप बताओ.
इंक्रीज होगा सर.
इंक्रीज हो रहा है. तो आप तो बस अपने रफ पेपर में ये रिलेशन लिखो, इफ आई डिक्रीज थीटा देन एक्स इंक्रीजेस. अब इन दोनों को देख करके बताओ ये इनवर्स रिलेशनशिप है या डायरेक्ट रिलेशनशिप है?
इनवर्स रिलेशनशिप.
इनवर्स रिलेशनशिप है. तो आंख बंद करके नेगेटिव हो गया ये.
यस सर.
अब इसका देखो, मैं थीटा को डिक्रीज कर रहा हूं तो ये वाला पॉइंट नीचे को चलेगा.
यस सर.
तो इसका मतलब मेरा y जो है, y कम हो रहा है कि बढ़ रहा है?
डिक्रीज हो जाएगा.
ये डिक्रीज हो रहा है. तो अब मैं क्या लिख रहा हूं कि व्हेन आई डिक्रीज थीटा माय y इज आल्सो डिक्रीजिंग. अब ये देखो y जो है ये थीटा को बिल्कुल एज इट इज फॉलो कर रहा है. दिस इज अ डायरेक्ट रिलेशनशिप एंड हेंस दिस विल बी अ पॉजिटिव रिलेशन.
यस.
तो अब आपको ये भी क्लियर हो गया कि आपके लिए कोई बंदिश नहीं है कि थीटा का साइन चेक करने के लिए आपको इंक्रीज करना है कि डिक्रीज करना है? यू कैन डू एनीथिंग, either you decrease or you increase, you will automatically get to know the effect of theta on x and y. Clear हो गया?
यस सर,
ओके,
थैंक यू सर।
एनी अदर डाउट्स? और किसी को कोई भी डाउट है तो पूछिए। आज अपन इतना ही कर रहे हैं, वी आर नॉट गोइंग टू द नेक्स्ट प्रॉब्लम, क्योंकि उस प्रॉब्लम को स्टार्ट करेंगे तो अपन फिनिश नहीं कर पाएंगे, एंड आई वांट टू रिलीज यू गाइस बिफोर द स्टार्ट ऑफ द नेक्स्ट लेक्चर। एनी अदर डाउट्स, प्लीज टेल मी।
नो सर।
ठीक है, बट प्लीज बी पेशेंट, डोंट गो अवे नाउ। मैं एक बार आपकी अटेंडेंस ले लूं और एक बार आपका अटेंडेंस कॉल आउट भी करूंगा, उसके बाद ही आप लोग क्विट कीजिएगा। सो प्लीज स्टे ऑनलाइन, डोंट गो अवे।